The interstellar object known as 3I/Atlas has become one of the most intriguing astronomical visitors ever observed, not only because of its rare origin beyond our solar system, but also because of the intense debate it sparked among scientists and the public alike. Discovered in July 2025 by the Asteroid Terrestrial Impact Last Alert System Survey Telescope located in Rio Hurtado, Chile, the object immediately stood out due to its extreme speed and highly unusual trajectory. Calculations showed that it was traveling on a hyperbolic path, meaning it was not gravitationally bound to the Sun and would pass through the solar system only once before disappearing back into interstellar space. This characteristic alone placed 3I/Atlas into an exceptionally exclusive category, making it only the third confirmed interstellar object ever detected, following the famous 2017 visitor Oumuamua and the later discovery of 2I/Borisov. From the moment of its identification, astronomers recognized that this object represented a rare opportunity to study material formed around another star system, offering a glimpse into the broader processes shaping the galaxy beyond our own planetary neighborhood. As observations continued, 3I/Atlas revealed a number of puzzling characteristics that fueled speculation and controversy. The object exhibited a bizarre, elongated shape inferred from fluctuations in its brightness, as well as changes in velocity that could not be explained by gravity alone. Its acceleration appeared oddly precise, prompting some observers to wonder whether conventional models of cometary behavior were sufficient to explain what was being seen. These unusual traits quickly captured attention beyond the scientific community, spilling into popular media and online forums where speculation ran rampant. For a small but vocal group of scientists and conspiracy theorists, the idea emerged that 3I/Atlas might not be a natural object at all, but rather a piece of extraterrestrial technology, perhaps a probe or artifact sent deliberately through our solar system. While such claims were controversial, they echoed earlier debates surrounding Oumuamua, which had similarly defied easy classification and inspired imaginative hypotheses about alien origins. Central to the renewed alien speculation was Avi Loeb, a Harvard astrophysicist known for his willingness to entertain unconventional explanations when observational data challenge established theories. In mid-2025, Loeb and collaborators released a draft paper suggesting that some of 3I/Atlas's properties were difficult to reconcile with standard comet models. He later discussed these ideas publicly, including on the Joe Rogan Experience, where he emphasized that while alien technology was only one of many possibilities, it should not be dismissed outright without careful consideration. These comments, amplified by social media and headlines, intensified public fascination and concern, especially when reports emerged in late December that the object had emitted a strange radio signal. To many outside the field, such signals seemed to reinforce the notion of artificial origin, even though astronomers cautioned that natural processes can produce radio emissions under certain conditions. Amid the growing speculation, other researchers focused on gathering more rigorous data to test whether 3I/Atlas truly behaved differently from known comets. A crucial development came with a paper submitted to Research Notes of the AAS, led by astrophysicist Marshall Eubanks. Rather than relying solely on telescopic observations from Earth, Eubanks and his team took advantage of measurements from two interplanetary spacecraft positioned at different vantage points in the solar system. This allowed them to precisely track the object's motion and directly measure its non-gravitational acceleration, a key factor in understanding its behavior. Their analysis showed that the apparent deviations in 3I/Atlas's trajectory were consistent with a well-known phenomenon in comet science known as outgassing, in which volatile ices sublimate as a comet approaches the Sun, producing jets of gas that act like tiny thrusters. Outgassing has long been known to alter a comet's speed, rotation, and orbital path, sometimes dramatically, and the patterns measured for 3I/Atlas matched those seen in many comets originating within our own solar system. The difference in this case was that the object was moving much faster and on a hyperbolic trajectory, which made the effects appear more extreme and harder to interpret without high-quality data. According to Eubanks, once these non-gravitational forces were properly accounted for, There was no need to invoke exotic explanations. The comet behaved, in essence, like a large icy body responding naturally to solar heating, shedding gas and dust in a way that subtly but measurably altered its flight. This conclusion significantly undercut claims that the object's motion implied artificial control or intelligent design. Physical observations further supported the cometary interpretation. Estimates suggest that 3I/Atlas possesses a substantial icy nucleus ranging from roughly 1,400 feet to as much as 3.5 miles in diameter, surrounded by a bright coma of dust and gas that became increasingly visible as it approached the inner solar system. As it raced past the Sun, reaching a staggering top speed of approximately 153,000 miles per hour when it crossed outside the orbit of Mars in October 2025, solar radiation drove intense outgassing from its surface. This activity not only explained the observed acceleration, but also accounted for variations in brightness and apparent shape. While the strange radio signal detected earlier had raised eyebrows, researchers pointed out that interactions between charged particles in the coma and the solar wind could plausibly generate radio emissions without any involvement of technology. By the time 3I/Atlas passed its closest point to Earth, the scientific consensus had shifted decisively away from alien hypotheses. The new data demonstrated that the object fit comfortably within the broader category of comets, albeit one originating from another star system. As it now speeds away from the Sun and gradually fades from view, astronomers recognize that opportunities to observe it will soon vanish, likely forever. This realization has prompted discussions about future missions designed to rapidly intercept or chase interstellar objects as soon as they are discovered. Some scientists argue that sending a spacecraft to study such an object up close, even briefly, could yield invaluable information about the chemistry, structure, and formation conditions of distant planetary systems, offering insights that cannot be obtained through remote observation alone. In this sense, the true legacy of 3I/Atlas may lie not in the fleeting excitement over alien speculation, but in the lessons it provides for planetary science and astronomy. The episode has highlighted both the power and the limitations of current observational techniques, showing how unusual data can be misinterpreted without sufficient context, while also demonstrating how advances in spacecraft tracking and multi-point measurements can resolve long-standing uncertainties. It has also underscored the importance of scientific skepticism balanced with openness, reminding researchers and the public alike that extraordinary claims require extraordinary evidence. Far from being a sign of visitors from another civilization, 3I/Atlas appears to be a natural messenger from afar, carrying within its icy core a record of processes that occurred around a distant star long before the Sun and planets formed. As interest turns toward the next interstellar object that may pass through our cosmic neighborhood, astronomers are already refining detection strategies and debating the feasibility of rapid response missions. Each such visitor offers a rare chance to test our theories of planetary formation on a galactic scale and to place our own solar system within a broader cosmic context. In that respect, 3I/Atlas has already achieved something remarkable. It has expanded our sense of what is possible to observe and study, and it has sparked conversations that may shape the future of space exploration. Rather than confirming fears or fantasies of alien technology, it has reaffirmed the richness and complexity of natural phenomena, reminding us that the universe can be astonishing enough without invoking intelligent design from beyond the stars.